All right, we're going to solve the following linear inequality and system of linear inequalities by graphing. So the first one, A, when we're graphing these, we want to graph the boundary line. So the first thing we're going to do is the boundary line. And the boundary line will be y equals negative 3x plus 4. And since it's greater than and not equal to, we're going to graph the boundary line dotted. All right, so this line is in the form y equals mx plus b. So when we graph this, we know the y-intercept is 4. So we'll plot that point 0, 4. And the slope is negative 3. So that means from this point, negative 3 over 1, the rise over run, I'll go down 3 and to the right 1. So another point on this line is the point 1, 1. We could do down 3 and to the right 1 again. And we could go left 3 or left 1 and up 3. So I want to make sure I graph this boundary line with a dotted line. So just some practice with graphing using slope. I'm just going to get rid of those steps so we don't have the stuff in here. Finish off our boundary line. All right, once we have the boundary line, we want to actually test a point and see which side the inequality falls on. So if we test the point 0, 0, which is on the left side of the boundary line, if we test that point 0, 0, back into our original inequality, y is 0, so that's supposed to be greater than negative 3 times 0 plus 4. We get a statement 0 is greater than 4, which is false. So what that means is 0, 0 is on the wrong side of the line. So we'll shade the other side. So I'm just going to use a highlighter, but we're just going to kind of shade in the left side of this line. And the boundary line with the shading would be our solution. All right, we're going to do the same thing with the system. Each one of the equations will be graphed. So we'll just call this first one line 1. So this boundary is going to be dotted because of the great less than. It's not equal to, so we'll make this dotted. So equation 1, we're just going to use intercepts. If x is 0, y would be negative 1. So again, we're graphing x plus y equals negative 1, the boundary line. If I plug in a 0 for y, I get negative 1 for x. So my 2 points are my intercepts, 0, negative 1, and negative 1, 0. And I'm just going to draw a dotted line representing that boundary line. So that one is 1. For 2, boundary line 2, we got the equation y equals 2x. And this one, because it's greater than or equal to, I will graph it solid. So the boundary line for 2, y equals 2x. What's nice about this one, it's in slope-intercept form. The y-intercept is 0. So I know it goes through the point 0, 0. And the slope is 2 over 1. So I'm just going to go up 2 and to the right 1, up 2 and to the right 1. And then I need a solid line through here. So that would be boundary line 2. All right, so for each one of these, we'll shade. We're going to test a point for each one. So testing a point for number 1, the dotted line, we can actually test the point 0, 0. So 0, 0 is on the right side of my dotted line. And if I test 0, 0 in the first equation, I get 0 plus 0. It's supposed to be less than negative 1. 0 is less than negative 1 is false. So I basically need to shade the other side. And so if I shade the other side of the dotted line, I'm just going to kind of use a light. I'm just going to draw straight lines here. The blue lines would be the shaded side of the dotted line. Let's use red line for equation 2. So if we test equation 2, y is greater than or equal to 2x. The problem is I can't actually test 0, 0 because it's on my line. So let's just test a point that's we know is off the line. How about if we test the point 1, 2, 3, 0. So if I test 3, 0, in my equation I get 0 is greater than or equal to 2 times 3. 0 is greater than or equal to 6, which is false again. So that means I want to shade the other side of the line. So I want to shade the other side. Whoops. Sorry about that. So if my red point is on the right side of the solid line, I want to make sure I shade the other side of the dotted line, or the shaded line. So the last part of this then is going to be shading the overlap. And if you notice, the overlap is this corner here with red and blue. So the last part of this is shading in the overlap region. So I'm just grabbing my shade tool here and highlighting this side. So the last thing we need to do is actually shade the overlap. So our shaded part is the solution.